Hello, everybody, and welcome to Launching an Automated Cluster with Lens. Today's webinar is sponsored by Mirantis and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media, and I'm excited to be your moderator for this special event. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to your questions during the event, but then at the end of the presentation, we'll discuss in greater detail some of the top questions that you ask. The Q&A panel is also a great place to let us know about any technical issues that you might be experiencing. A browser refresh is going to fix most of those, as far as audio or video or slide advancement. But if that doesn't work, just let us know in the Q&A and we will provide further technical assistance. Second, in the handout section of your webinar control panel, you'll find that we're offering several resources. There's a DevOps Care data sheet from Mirantis, and then you'll also find links to a few Actual Tech Media resources like the Gorilla Guide Book Club and the ATM Event Center. I encourage you to access those resources now and share them with your friends and colleagues. Third, at the end of this webinar, we will be awarding a $300 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can be found in your handout section. Just scroll to the bottom and you'll find the prize terms and conditions there. Finally, one of the best benefits of an event like this is the opportunity to ask a question of our expert presenters. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. At the end of the event, we'll look at all the questions, pick out the very best one, and contact that prize winner. And with that, let's get to today's fantastic session. So it's my pleasure to introduce you to our presenters today. We have Edward Ionel, who's head of developer relations at Mirantis. And joining Edward is Nana, who many of you will recognize from Techworld with Nana. So welcome, Edward and Nana. Thanks for being here.
Thank you so much for having me. Couldn't be more excited to be here with everyone joining across the world. Looking forward to this session, and thank you.
Hi, everyone. Thanks for joining in, and I'm really excited for the session as well.
Excellent. Well, Edward, take it away.
Absolutely. I'm going to share my screen, if you do not mind. Just real quick. And I imagine everybody can see my screen now. Maybe yes, if you can see my screen.
Yeah, we can see it.
Yeah.
Awesome. So today we're going to be talking about Lens, the Kubernetes IDE, which the world uses to run their Kubernetes. So Nana, maybe you could share with us a little bit about the challenges that many people may be facing when working with DevOps or Kubernetes initiatives.
So first of all, I think everybody can agree that Kubernetes has become very popular. And it is actually one of the tools that we see all the projects are adopting. And because it has become such mainstream project, a lot of companies, a lot of engineers who actually kind of shied away from Kubernetes also start using it just because everyone else is doing it. But the main challenge with Kubernetes adoption is actually that Kubernetes happens to be pretty complex, right? So the learning curve for the engineers is pretty steep, and also a lot of engineers, either they don't have time to dedicate to learning Kubernetes, and also it's too low level, so to say, to kind of start working with it. So that's, and I'm talking just to get started with Kubernetes and just be able to do like very simple use cases. But of course, simple use case is not the production ready cluster, right? So you have on top of that, you have to consider security, you have to consider best practices and all this stuff, and to make it production ready. So that path, like taking it from just getting started with Kubernetes to the production ready cluster, is actually really challenging for a lot of engineers. And I know that from my experience of consulting the companies and different projects of how they approach Kubernetes, and also from my subscribers and viewers through the comments, for example, and feedback that we get on Kubernetes videos or tools that are related to Kubernetes. And also some engineers, they're just not really interested in learning a tool that is just, really that has the whole package with it, because they don't have time or they don't have interest to do that on top of their already existing developer tasks, so to say. So one interesting thing to define when talking about Kubernetes is that you actually have two main roles in Kubernetes, and one of them is, and it's really important to differentiate between the two, because one of them is a Kubernetes user, so to say. So these are typically developers who deploy their applications to it, and we have Kubernetes administrators, right? Because in order to be able to deploy to the cluster should exist. It should be configured properly, ideally. So that's the role of Kubernetes administration. And these two are usually separate. And these are two different skills, a group of skills and knowledge, basically. And we have challenges on both sides, right? And also important to differentiate between the stages, right? We have the initial setup of the cluster, which is setting up the cluster to make it like the simple entry level of being able to connect to the cluster and start working with it. And then there is maintenance and making it basically updating the cluster, integrating some technologies and tools that maybe developers need, some security configurations, adding some stuff and so on, right? So we have these two roles and two stages, and the combination of these basically, in each combination, we have set of challenges. And I'm sure that from our viewers, we have some developers, software developers who have to work with Kubernetes. We have some DevOps engineers, maybe we have some Kubernetes administrators that do this like on a day-to-day basis. And I know that you have like your own set of different challenges when working with Kubernetes. So that's why when talking about the challenges, it's important to differentiate between these roles and stages. And one of the challenges also, and it's actually shown on the previous slide, where you see that Kubernetes, out of the box, basically offers you this simple set of things that you can just use to deploy your workloads. But a lot of tools you have to actually integrate, these external tools, in order to make it even production ready, right? So things like secret management, maybe you have to use Vault, or you have to add ingress for the routing and traffic management, networking, container runtime. So all of these things are actually external tools that you don't get out of the box with Kubernetes, right? So you have all these integrations, and for each integration, you need knowledge, obviously, for each tool and integration, and it needs maintenance. So there are a lot of things happening in Kubernetes that adds to the complexity of already complex Kubernetes architecture. So that's another thing. And from the developer perspective, obviously the most challenging thing is getting started with Kubernetes, because you have to understand the components, you have to understand the architecture, a little bit of how it works, how do you deploy your workloads into Kubernetes, how do you connect to it. kubectl is the main tool that developers usually would use, and you have to know all the commands that kubectl offers. How do you check what workloads are running in the cluster? How do you check whether your pods or your workloads are running successfully, right? If something goes wrong and a user has an issue, how do you check what happened in the cluster? What happened to your application inside the cluster? So these are generally some of the challenges of getting started with and working with Kubernetes for a lot of engineers. And there are a lot of tools who try to solve different aspects and challenges of Kubernetes, who try to abstract away this low-level complexity of Kubernetes. Some tools actually succeed in abstracting that away for developers, but the work basically shifts to the Kubernetes administrator or DevOps side. So it's kind of pushes the complexity more to that role. And again, there are lots of different tools, and Lens is actually one of the really good examples of tools that solves a variety of these challenges that engineers of different roles have, right? And Edward can actually introduce Lens and kind of tell us a little bit of how Lens tries to solve these challenges.
Absolutely. Nana, first, thank you so much for walking us through all of the complex challenges that you have to face when working with Kubernetes, regardless of your persona or role. Yeah, so here we're going to be taking a look at Lens, the Kubernetes IDE. Lens is a graphical user interface built to allow anyone to achieve full situational awareness of everything that's happening within their cluster, as well as the workloads deployed on top of that cluster. So as we saw on the previous slide, even when you've set up that production grade environment and you've leveraged all of these different technologies and tools and plugins to create that environment, from your networking to your service mesh to your ingress and all of these different complex technologies, there's still a whole nother challenge, which is really maintaining or observing or monitoring, managing that Kubernetes cluster and the workloads within. Generally speaking, people working with Kubernetes are going to have to bounce between various different technologies, tools, documentation, command line interfaces, dashboards, Helm CLIs, and so forth. This is where Lens comes in. Lens is really going to eliminate the need to work with multiple different platforms, tools, and technologies while allowing you to achieve full situational awareness of everything that's happening in that Kubernetes cluster. So for example, and we'll get to this a little further in the presentation, an operator will very easily be able to switch between a proof of concept cluster, a staging cluster, a development cluster, or a production grade cluster while achieving that full situational awareness of everything that's actually happening within that cluster itself. So they'll be able to see if there's a drop into lifecycle management. They'll be able to see what the capacity of the cluster is, how many resources are being used, where the pods are, what containers are associated to those pods, and so forth. So Lens really is going to be a tool that you leverage to really improve time to market for your workloads and your deployment for business critical applications. It's going to significantly increase productivity when working with Kubernetes, and hopefully it's going to increase your return on investment with Kubernetes. I do want to mention that Lens is built on an open source project called OpenLens that is maintained primarily by Mirantis and some members of our community. And again, Lens is built on top of that OpenLens project, and Lens works with any certified Kubernetes distro. It is also currently free, and we'll be taking a look at some centralized features today as well. But we'll jump into that in further depth in just a moment. So here is a slide to really showcase our stats and the growth of Lens. So we launched Lens roughly 2.5 years ago, right before the pandemic hit, and we've seen significant growth over the last couple of years. So currently, some of these stats are a bit outdated. As you can see, they were updated almost a month ago, but we have over 650,000 unique users that are leveraging Lens on a day-to-day basis, with over the actual number for clusters over roughly 1.5 million, 2 million clusters are actually deployed on top of Lens. And of course, we have some amazing GitHub stargazers from our wonderful community for our OpenLens project. So I touched on this just a bit on a previous slide, but really, how is Lens providing value to our users? Outside of all of the features that Lens provides, from multi-cluster management to troubleshooting applications and so forth, there's actually some business critical value that Lens brings our users and teams and organizations. One, Lens is going to really accelerate that Kubernetes time to value. We've learned that Lens allows anybody working with Kubernetes to adopt Kubernetes significantly faster. Over 95% of users that filled out this survey mentioned that Lens has helped them learn Kubernetes significantly faster. Lens is also going to eliminate the complexity with Kubernetes, and we're really going to talk about this when we do the demo itself, and that's going to give everybody a clear understanding of how it's removing that complexity. But since it is a graphical user interface that allows you to interact with multiple clusters, your workloads, and so forth, you're going to be able to get real-time messages and events that are going to really allow you to understand everything happening in your cluster. And that's really going to be eliminating that Kubernetes complexity. We also see that Lens eliminates the amount of tools either a developer or an operator is going to have to use when working with Kubernetes. The number that we've seen on average from our surveys with our users is you're really consolidating 4 tools into one. You're consolidating a Kubernetes dashboard, you're consolidating a CLI, we have some documentation, and you'll also have the ability to consolidate with our new features some of the image scanning vulnerabilities that you may be leveraging other technologies for, like Sneak or Aqua Security and so forth, right? The third item, which is awesome, and it's really my favorite thing behind Lens, is it's really going to increase your productivity when working with Kubernetes. On average, our users are saving 20% per week when they're leveraging Lens. So if we break that down, that means they don't work on Fridays. That's probably not true at all in terms of whether they work on Fridays or not. But what we see is they are saving on average an hour and a half to 2 hours per day, which is going to give them roughly 8 to 10 hours back in their day-to-day responsibilities, which is why it's improving that productivity. So Nana, maybe you could talk a little bit about some of the challenges and the workflows that developers need to understand or work through when working with Kubernetes. And then from there, I could talk about how developers can work with Lens in their environment.
Yes, absolutely. So in the development lifecycle, Kubernetes comes a little bit later, which is when I need to deploy. So basically, I have done my development. I have created this feature. It has been, gone through the first stages of the testing, maybe, and I need to start deploying it, right, to different stages, like maybe development, testing, whatever. So that's where Kubernetes comes in for the developers, right? So in terms of the use case or the process, so what developers have to do in terms of Kubernetes on that specific place. So this could be a role of a developer, or it could be also a dedicated DevOps engineer that has to do that. And that is when I have to integrate my CI/CD pipeline basically to deploy my application automatically to Kubernetes cluster. And this step, so to say, can actually have a lot of challenges. And again, this comes back to the complexity of how Kubernetes works, because you have to, as a developer or DevOps engineer who does this step, has to understand a lot about Kubernetes to be able to actually implement this step, right? So what are some of the things that we have to consider in this case, or what they have to do? So first of all, they have to understand the things about security and integration. So how do I even connect my CI/CD tool, whatever I'm using, whether it's Jenkins or GitLab CI/CD or whatever it is? How do I connect this to Kubernetes? And there are different tools, and you have this push model where you push the deployment to cluster. There's a pull. We have the agent of the CI/CD tool inside the cluster that pulls. So there are different variations. There are different tools, which is great, but it also has an disadvantage, because it could be overwhelming for the developers, because how do I know which tool to use? Which model is better, right? What is the best practice? So they actually have to do or they have to learn a lot of these things in order to be able to do that. Then of course I have to worry about security. How is it secure? How do I create own user for CI/CD pipeline in Kubernetes? How do I do that? Or maybe I let Kubernetes administrator create that. Another important thing is also release management, right? So how do I even deploy? And there are different concepts of release. You can do like blue-green deployment. You can do deployment in stages, right? Instead of just switching to the new version. So a lot of that release management is also very Kubernetes specific. So you have to understand how that all works. Another question is simply, how do I even create this deployment manifest, right? Do I work with Kubernetes manifest? Do I use Helm chart for this? So you see that for one step, you have lots of options, which, as I said, is because you have the flexibility of designing your workflow as you wish, but you also have the disadvantage because you have to kind of go through and analyze these different options to choose the best one for you. And because these are not really easy, you have to understand a lot about Kubernetes and these tools to make this happen. So that could already be a pretty challenging thing for developers or DevOps engineers. Again, there are lots of tools that try to solve these problems, and having the visibility of the things and having some kind of abstraction of that is really important, I think. And this is again something that Lens the kind of focuses on, to give you that visibility, so you don't have to work with some command line tools and lots of different tools, and have this kind of centralized in one place. So Edward will actually tell us that how does Lens actually solve these kind of specific challenges in terms of Kubernetes.
Absolutely, Nana, thank you. Yeah, as Nana mentioned, there's so many different responsibilities and steps when it comes to developers' life cycles, right? And the workflow that they need to be working within to actually deploy applications at scale. So as Nana mentioned, they need to write some form of proprietary code in an IDE. They need to leverage some form of terminals. They need to containerize their application. They need to push the application to some form of repository. They need to leverage CI/CD pipelines to deploy that application on top of Kubernetes. Now, this is where Lens comes in. So traditionally speaking, Lens is going to come in after, for developers and DevOps engineers, or specifically more developers, Lens is going to come in after that workload has actually been deployed on top of Kubernetes, or when it's being deployed on top of Kubernetes. Lens is going to give developers, that phrase I like to use, that full situational awareness of everything that's happening with their workloads, from the deployment to getting full observability, to troubleshooting, to downloading logs, to reviewing logs, to obtaining real-time messages, to troubleshooting the application on top of their Kubernetes service, and so forth. So Lens really is going to give you that bird's eye view into your cluster and the deployment that was deployed, or that workload that was deployed on top of Kubernetes, and give you that full situational awareness of everything that's happening. Again, from your observability, from your deployment, to monitoring the workload, to understanding your pod statuses, to downloading real-time events and logs, to troubleshooting, and so forth. And as mentioned, Lens, again, is going to work with any certified Kubernetes distro, regardless of what you're using. You can be leveraging Mirantis Kubernetes Engine. You can be leveraging K0s. You can be leveraging a public cloud provider, or Minikube, or Micro K8s, and so forth. So really, Lens works with any certified Kubernetes distro. And for developers, Lens comes in at the end of their workload to really understand how, or their workflow, to really understand how their workload is performing on top of the environment. The next role is operators, or cluster administrators, or site reliability engineers. And here I'm going to hand it back over to Nana for her to share with us a little bit about what the day in the life is for them, and the challenges they may be facing. And then we can transition into me showcasing really where Lens comes in into their workflow.
Yeah, so this is actually a super important part, or very important task, so to say, in terms when talking about Kubernetes. And the reason for that is because lots of Kubernetes clusters actually progress to becoming really big. Like, you have thousands and 10,000s of pods and workloads inside, and a lot of companies actually use the same cluster to kind of divide it into multiple parts, and kind of have multiple teams deployed to that. Or you sometimes have different environments on the same cluster, so you have lots of different variations, and your cluster can become super complex. You may have lots of components. And the worst thing you can have is a huge cluster with lots of workloads of different teams, and no idea or no visibility of what's going on inside, right? Because even though Kubernetes offers this self-healing feature of, if one pod dies, it kind of tries to restart it, there's still a lot of things that can go wrong with for your workloads. And you will not be able to see anything or to get any information on that. And having a visibility inside your cluster is extremely important, because you want to know, both as a developer, you want to know how are your applications performing. Are they slow? Maybe one of the pods is, or one of the applications, if you are deploying microservices, for example, maybe one of the services is getting bombarded with lots of requests, so it's getting slower, and kind of becomes the bottleneck. Maybe you don't get the request all the way through the chain, right down the chain, or maybe you have some issues connecting to the outside services. Like, you can have multiple things that may go wrong, but also on the Kubernetes administrator side, because when you're administering the cluster, you want to know how each level and layer of your cluster is performing. You want to know how is your infrastructure doing. Are you running out of memory, out of CPU, because one container has a bug inside, or it's being attacked, so it kind of eats up all the resources. You want to know on the Kubernetes platform level, maybe the control plane has some issues, maybe the worker node processes have some issues, and then you have the application layer, right, where again many things can go wrong. So you need that visibility as a Kubernetes administrator as well, to know that something is going wrong, so you kind of proactively get in and fix that. And what lots of the ideal state of having a proper visibility and traceability within your cluster is that you can prevent things before they actually happen, right? And that's the most ideal state, where you have a dashboard or some kind of visualization of your clusters, and you can basically see exactly what state, what health state different components are in. And again, you can proactively try to fix stuff and adjust stuff, instead of just being reactive to when things break, kind of getting into a panic mode. And that's again a super important part of engineers' work. So yeah, Edward, take us through how Lens actually solves some of these challenges.
Absolutely. Thank you, Nana. Yeah, so Lens is going to come in at the beginning of the workflow or workday for operators, cluster administrators, or site reliability engineers. And I love that phrase that Nana used. Lens is going to allow you to be proactive with your cluster compared to reactive. And specifically what I mean by that is Lens is always going to allow you to understand the health and status of your cluster, real-time events, if there's a drop in the lifecycle management, and also give you all of the necessary tools to be able to troubleshoot and identify really what is happening with your cluster. So you're going to be able to take a look at the capacity of your cluster, the resources within your cluster, images, nodes, pods, operators, the entire network, the API, the scheduler, the logs, resource quotas, and so forth, all in one beautiful place. And that's going to really accelerate your workflow, because then you can also switch between cluster and cluster. So traditionally, and I'll be showcasing this in our demo, traditionally, cluster administrators or Kubernetes users are going to be constantly in the command line, taking a look at everything, writing complex kubectl command lines, and then they're going to have to switch to another cluster, and they're going to have to make sure they're working in the correct context of that cluster. Lens is going to eliminate that, specifically around being able to switch from cluster to cluster while always maintaining the correct Kubernetes API endpoint or context, ensuring you're working with the correct cluster you should be working with, right? And again, it's going to give you that full visibility, that full situational awareness of everything that's happening. So to the challenges that Nana mentioned, Lens is going to be more of a proactive feature, tool, resource compared to a reactive one, where you're going to be scrambling to identify what's wrong. You're going to be scrambling to increase the capacity of the cluster, and so forth. Lens is really going to allow you to get that full situational awareness at the beginning of your workflow, the beginning of the life cycle, and you're going to be in a proactive state, which I think is extremely important when working with Kubernetes. It's very challenging to be in a proactive state, I would mention, but it's extremely beneficial to move away from a reactive state where you're trying to, let's say, fix a production grade Kubernetes environment cluster with business critical applications running on top of it, and you have no idea why that environment is down. And now, for example, your business critical applications are not performing or not working. And that's where the business is going to lose thousands of resources very, very quickly. So we already spoke about the Lens desktop, but we can give a little bit of a high level overview again, who it's designed for, who it's for. I think Nana mentioned this quite a lot, but really it's for developers, DevOps engineers, site reliability engineers that need to work with Kubernetes on a day-to-day basis. They absolutely do have different roles. So again, cluster administrators, they'll be taking a look at the health and the status of the cluster. managing multiple different clusters, taking a look at each and every single one. Developers or DevOps engineers are generally going to be a little bit more focused on the workloads and understanding how those are performing on top of the environment. But really, Lens is going to provide value for both of these personas through increasing productivity, efficiency, and the return on investment that you would like to see when working with Kubernetes. As mentioned earlier, works with any certified Kubernetes distro. It's built on top of, or it's built from an open source project called OpenLens, and it is currently free. Nana, maybe you can talk a little bit about some of the challenges that people may be facing when trying to give, let's say, developers or give team members access to a Kubernetes environment. Let's say there's a new team member that joins a DevOps team, or and they may need access to this Kubernetes environment. I know there's a ton of complexities and role-based access control and different security vulnerabilities and permissions that need to take place. Maybe you can talk to us a little bit about that particular challenge of really giving people access to Kubernetes environments in a secure fashion.
Yes, absolutely. So this is actually a very interesting topic, and it's also interesting to see how big companies try to solve this issue. So to talk about, to kind of have also wrap up in comparison between this part and the previous one. So we talked about the DevOps and DevOps developer and DevOps engineers role in Kubernetes, which is the deployment part. And we have this SRE role, which is more kind of working with the monitoring and visibility. And then you actually need sometimes a group of people, group of engineers dedicated to actually maintaining or setting up initially and then maintaining the cluster, right? So that's right. That could actually be a full-time job, and that's why, like, a lot of companies try to push everything like DevOps engineer. You have to do anything. You have to do everything. But this could actually be own dedicated full-time job, right? So what happens here is that when companies start to switch to Kubernetes, they have lots of teams that say, I want to use Kubernetes as well for my applications, because they're kind of convinced that Kubernetes has all these benefits. So they all kind of want to switch. So what happens, the first challenge is for the company, okay, do we have separate clusters for each team? Do we have to manage basically this complete cluster for each and every team? And that creates obviously an overhead, because now you have the cluster obviously has control plane and the worker nodes, right? And managing that control plane, which is the head of the cluster, with the security, with proper security, with proper replication, because you can't just have one master in production, right? So managing the control plane is a lot of overhead, and you need really people who know what they're doing, unless you're, or actually, even if you're using managed Kubernetes services, you need a Kubernetes administrator. So a lot of companies say, you know what, we can't, or we don't want to have this overhead and this effort. So let's start developing one Kubernetes cluster, a huge Kubernetes cluster for the entire company. So when a developer team comes to us, here is your virtual or your piece of the cluster, and you can use this and start deploying your applications to that, right? And this sounds like an amazing and good idea, which is, it is kind of long term. However, that has additional challenges that it brings with that, and that is exactly what you mentioned, Edward, is how do I manage? So you have these Kubernetes administrators and people who are setting up this one master cluster, so to say, in the company. So how do I manage the access to this master cluster to lots of different teams, right? Because obviously I don't want one team to mess up something in my company-wide cluster that affects hundreds of other teams, right? So how do I manage permissions? How do I limit the resources that they can use and they can access? How do I make sure there is a clear separation between what this team can see from other cluster resources. How do I make sure that the shared resources are not affected by any team, or no team has access to that, right? Or within the teams even, right? So I have a developer group, but not everyone in that developer team needs the same access, right? You may have a DevOps engineer who needs a little bit more access to that piece of the cluster, right? Some have virtual clusters, whatever, there are different options there as well. I may have a junior engineer who I kind of want to ease into Kubernetes, so maybe give like read access. So how do I manage this granular access, but also while keeping that security, so to say, in check? How do I still make sure that it's developer friendly? So if a team of developers comes to get their piece of cluster, it's not like a huge trouble for them to get started, right? As a company, how do I make sure they can get started easily? And then finally, the last challenge, which is also not a small one, is how do I make sure even the parts that developers have access to, how do I make sure that they are actually deploying with best practices and with security practices, right? And there are, again, different options here, how administrators can enforce some configuration rules, etc., using automated policies and so on. So this is a whole new topic, or its own dedicated topic, and a lot of challenges that companies are actually facing here. So it will also be really interesting to see how Lens actually handles some of these things.
Absolutely. Nana, thank you so much. So first, I do want to mention that Lens Cloud is a centralized feature on top of Lens. I think that's important to mention, and it is a paid feature. So I just want to make that clear. Yes, it is free to get started with as a trial for Lens Cloud. Lens is free, and Lens is remaining free. That being said, Lens Cloud, this feature specifically around Namespaces is going to be a paid feature, but you can get started with it for free for roughly 30 days. Now, the neat thing behind Namespaces or Lens Cloud is it gives cluster administrators the ability to share access with a team member, an entire team, a support team, without ever having to expose the kubeconfig file to that team member or that team. Specifically, what I mean by this is, generally speaking, when somebody has access to a kubeconfig file, there's role-based access control associated to that kubeconfig file, which is going to give them specific permissions to interact with that cluster. Normally, cluster administrators will have full access into the cluster with full permissions, but they will begin to generate multiple kubeconfig files for different team members or teams. So if I have a team of developers that need to access specific microservices or specific workloads within my Kubernetes environment, I'm going to generate a kubeconfig file with the correct role-based access controls that is going to allow them to only see a specific part of the cluster. The way that works is through namespaces. Namespaces should be thought of as folders within your cluster where you will be able to see specific resources running within that namespace. So if I wanted to give a team of developers access to a namespace that has, let's say, 5 applications running, I'm going to have to generate a kubeconfig file and share it with that team. The problem with this is how you share that kubeconfig file and what the user does with that kubeconfig file. So generally speaking, to share a kubeconfig file, you may put it on a hard drive, hand over that hard drive to your colleague. You may send it via email, which I don't recommend. You may leverage some form of VPNs to access the kubeconfig file and download it from a server or a browser, right? And there's many different vulnerabilities that come into place when you take these particular items or actions. For example, if you share via email, which I absolutely do not recommend, if something happens to that email and somebody gets their hands on that kubeconfig file, they'll be able to do whatever they would like to that cluster dependent on the role-based access control of that kubeconfig file. This is where Namespaces comes in. Namespaces or Lens Cloud is going to allow you, as mentioned earlier, to share access to a Kubernetes cluster without ever exposing the kubeconfig file to that colleague. So the neat thing behind it, and we'll be demonstrating this, is in a matter of minutes or seconds, I would actually be able to give everybody on this call access to a Kubernetes cluster and give them specific permissions towards that Kubernetes cluster. So the way we like to use Namespaces here at Mirantis and our customers as well is I may have a team of developers that need to access a namespace, let's say called Blue. And within that namespace called Blue, I have 10 business critical applications that this team works with. I will be able to create a space, add a cluster to that space, create a team within that space called Developer Team Blue, and then on that team, I will be able to adjust the role-based access control to match that team, meaning that team will now only have access to the namespace Blue. What's neat about this is it really allows you to scale your efforts and have a centralized location in terms of understanding who has access to what, which team has access to this namespace, which team has access to the entire cluster, and also giving you somewhat of a Google Drive functionality where you'll also even be able to see what people are doing within that Kubernetes cluster. So I can share with the team developers and I can see that Nick has accessed this particular workload and he's downloaded the logs. I would be able to see all of this information in a detailed report that's really going to allow us to keep this extremely secure. Now, the neat thing behind this as well is the fact that I can grant and revoke access in minutes. And the revoke access, I think, is extremely important. As mentioned, once you give the kubeconfig file to somebody, regardless of the role-based access control, they now generally always will have access to that Kubernetes cluster and the specific resources within based off of the role-based access control. With Lens Cloud or Namespaces, you're never actually going to expose the kubeconfig file, meaning I can give Nana access to my Mirantis Kubernetes Engine cluster immediately, but I can also revoke access immediately, ensuring that we're onboarding new users very quickly through an email link or a web link with no hassle, as well as ensuring that we are leveraging the best security practices and revoking access if necessary from a colleague or team member. From here, we are actually going to jump into a demo. So we only have roughly 15 minutes left. So I want to make sure that we're actually taking a look at the meat of Lens, the desktop application, the Kubernetes IDE. So I know we talked about several different things that we'll be taking a look at. So I'm actually going to minimize this screen, navigate real quick, and just give the audience some resources that they can leverage in terms of being able to access a Kubernetes cluster in moments. So of course you have Minikube, one of the easiest ways to deploy a cluster on top of your local environment. You have K0S, which is also built by Mirantis, maintained by Mirantis and Team Lens, which is a open source Kubernetes distro. It's lightweight, built for edge and IoT use cases, but also you can actually skip this entire process and just leverage Lens instead. Lens is going to provide you with a cluster directly in your desktop application for free for 30 days. Now, that being said, Lens is free and you do not need to leverage this cluster that we provide for you. But if you're new to Kubernetes and would like to get started with Kubernetes, Lens is actually going to give you everything you need to be successful when working with Kubernetes. So I'm going to jump into somewhat of an extensive demo here. So I hope you all bear with me. But when you launch Lens, you're actually going to be in this catalog screen. And in this catalog screen, we provide you with several different resources that you can leverage when working with Kubernetes. So you have your general resources. This is more specific to the application itself, right? Changing preferences, changing the color palette of the desktop application, adding extensions on top of Lens and so forth. But if we navigate to our clusters, we can currently see we have various different clusters currently connected to Lens. As mentioned earlier, the way you are going to interact with your cluster through Lens is you simply add a kubeconfig file to Lens. You're not installing anything on top of your cluster. I want to make that clear. Instead, you're generating your kubeconfig file and adding it to Lens through several ways. One way, Lens can actually automatically detect a kubeconfig file directly on your operating system. Or you can copy and paste a kubeconfig file directly from your operating system, or you can search for it through the normal way where you would upload something to a desktop application through just finding it in your folder, syncing the kubeconfig file, and so forth. So here we can see I have several different Kubernetes clusters currently added. Now, if I click into my Mirantis Kubernetes Engine cluster, as mentioned earlier, you're going to get that full situational awareness of everything that's happening within your Kubernetes environment. So right now we're more focused on the operator, but we'll definitely talk about developers as well. Here I can see how my cluster is performing in the last hour from my master to my worker nodes, from my CPU to my memory, as well as the capacity of the cluster and the resource management. So here I can really see immediately at a bird's eye view how this cluster is performing without even having to write any command line. Now, why is this powerful? This is powerful because I immediately can switch to another cluster. And here, this is a perfect example of a cluster that I only have specific access to. So I don't have full access, but here I only have access to a specific namespace, and that namespace is blue. But the neat thing behind this is I'm able to immediately switch to this Kubernetes cluster, understand the version here, and this is what I mentioned, where Lens is going to connect to the correct context of your Kubernetes cluster and the API endpoint. Now we can see the Git version, version 1. I can navigate back to my Mirantis Kubernetes cluster, access the terminal. We'll just clear this even though there's nothing there. kubectl version, and we're going to see that the version is different. This is ensuring that we're working in the correct context of our cluster at all times. So again, the ability to switch between cluster and cluster and achieve full situational awareness is one of the main value propositions that Lens brings to operators, cluster administrators, or site reliability engineers. Now, Lens goes much deeper than just this bird's eye view. On the bottom half, we can actually see real-time warnings or events, as well as a timetable or a timestamp of when this was last seen. So if I click into this message, we can see there's this pod. We have some admin functions we can perform on the right-hand side if you have the correct role-based access control. But we can see the status of this pod is pending, and we can see that there's this error message here. This error message is a little bit more specific to developers or DevOps engineers. This error message is telling us that Kubernetes has failed to actually pull this image from this particular repository. Now, traditionally, when working with Kubernetes, to be able to see something like this, you're going to have to run some command lines to really understand how your pods and your objects are performing within your cluster. So here I ran a quick command line or kubectl command line saying get pods, and it's going to give us the status of some of the or all of the pods that are currently in our environment. So we can see blue image pool back off. That's the same pod that we just took a look at here. Blue, we could take a look, failed to pull the image. This is an error where it's image pool back off. And if I access my terminal again, we can always see these messages by running some command line. But Lens is allowing us to see this immediately. And this is only telling us what the status is. But to actually understand what the error is going to be another command line, right? Which is going to be kubectl describe pod. We're going to minimize this. And I'm actually going to navigate over to my overview screen where we're going to be able to see all of the resources that are currently running in our cluster, as well as, again, the status of that particular resource object and so forth. So yes, we can see it through kubectl, but Lens is going to allow us to see that through the graphical user interface and allow us also to begin troubleshooting immediately. Here we can see all of the pods that have failed, and here we can see all of the pods that are pending. So clicking into this pod, we're going to be able to get real-time messages, as well as all of the details associated. Here we can see the exact error message, right? But to do this through kubectl, I need to copy this pod name, navigate back to my terminal, and we're going to describe the pod. And here it's going to give us the exact same thing that Lens is showing us. But of course, we're going to have to run a ton of kubectl command line just to see the most basic items. So here we can see that the state of the pod, it's waiting, pending. We can see what the reason is, image pool back off. That has to do with Kubernetes not being able to actually pull the image to the environment. And then on the bottom half, we begin to actually see what the error message is. Now, we need to take this a step further, right? So now me being a developer or DevOps engineer, I can understand, okay, I see that Kubernetes is having challenges pulling this image, and we can see the logs and the messages and so forth. Traditionally, when working with a much more complex error compared to just saying it failed to pull the image, you're going to have to want to grab the logs of the particular pod itself. So I can click into this pod. On the top right-hand side, I can also immediately see how this pod is performing from CPU, memory, network, file system, all of the details associated to this pod. But I also have the ability to perform some admin functions on the top right-hand side, again, based off of your role-based access control. I can attach to the pod, I can shell into the pod, I can view the pod logs immediately as well without having to write any command line. Interesting. And so forth. And I also have the ability to edit this resource in real time. So for example, we can see that we had that error message. I can go into the YAML code itself for this pod and begin configuring, changing, troubleshooting, and deploying this all in real time. So Lens is going to really give us that full situational awareness, as mentioned, across every single object in our cluster, from our pods, our deployments, our daemon sets, our stateful sets, replica sets, so forth. Now, Lens comes with pre-built-in Prometheus if you don't currently have it on your cluster, and that's why you get to see these beautiful graphs of how everything is performing. We can even access our config maps. We can create secrets all in real time as well through Lens. We can access secrets. We can view the secrets. We can hide the secrets. We can edit the secrets and so forth. So Lens very much is a Kubernetes IDE. You can leverage kubectl through the terminal, which is always going to connect to the correct kubectl version as well. But you can also work directly with YAML and create resources directly in Lens as well. So if I want to deploy an Nginx deployment directly to my cluster, I actually have the ability to do so directly through Lens. I can copy and paste, click create resource, and just for example purposes, you can bring in your own YAML, copy and paste, create and close, and it's going to deploy it successfully. Now, there's some other cool admin functions that you can perform as well. If I find this resource that I just deployed, Nginx, pods, I actually have the ability to scale these deployments too, all through Lens, just through the UI. So I can scale this up or scale this down directly in my cluster, scale it up. We'll see that the pods begin to be created, as we can see, pending. We can see when it was created, begun to be created 7 seconds ago, and so forth. You can also access your network, services, endpoints, ingresses, and so forth. So we're coming to the top of the hour, and we've gone through quite a bit of different things, from being able to understand full situational awareness from an operator standpoint, switching from cluster to cluster while always maintaining the correct context of that Kubernetes environment and that cluster itself. We took a look at how developers would access this. They would take a look at their pods, their deployments, grab their logs, run some kubectl command lines if they choose to do so. But the neat thing behind Lens is it's really eliminating the need to run kubectl command lines. And it's also giving you a clear view of how everything in your cluster is performing without having to run command lines. Traditionally speaking, to do this, it's going to take various different steps and so forth. You can also adjust access control, so your role-based access control. You can deploy Helm Charts directly through Lens as well. So I can find a Helm chart that I'm interested in and just install it directly to my environment if I choose to do so. I won't do this here for demonstration purposes, but you can see that there's so many different use cases here with Lens that it's going to improve your productivity. On the right-hand side, I know we only have 3 minutes left, so I apologize, everybody. I'm going to try to get through this quickly. On the right-hand side, we can see some spaces that I'm a part of. For demonstration purposes, and since we're almost at the top of the hour, I won't be showcasing specifically how you share access to that Kubernetes environment, but instead, I will showcase that I can see various different clusters that are shared with me in these different spaces. So when I navigate to a new space like Edward's space and I go to home, I can see I have 3 clusters here. But if I navigate to, let's say, Team Reevent space, I can see there's 4 clusters here that I can access. Or if I navigate to Edward and Nana's space, there's a cluster here. And Nana now has access to this cluster as well. The thing is Through Namespaces, you're going to adjust your role-based access control and so forth. The last thing I want to mention is through Lens, you are given a dev cluster. So you can very easily access a development environment cluster all through Lens directly in the desktop application. So this is going to give developers a quick environment that they can leverage that is optimized for development environments. Again, not production grade environments that they can go get a Kubernetes cluster, leverage Kubernetes, deploy some resources to Kubernetes, deploy some application workloads and so forth, all through Lens without having to actually wrestle with kubectl or deploy a Kubernetes cluster and so forth. And as you can see, I can switch between cluster and cluster while always maintaining the correct Kubernetes API endpoint and the context of that cluster itself. So with that, I'm going to stop the demo itself now, but you can see there's so many different use cases that you can leverage or solve or and so forth when working with Lens, from operational use cases to developer use cases, and also the ability to see every single resource within Kubernetes extremely easily. So this is Lens, the Kubernetes platform, the Kubernetes IDE. It's a desktop application that is free to use, built on OpenLens, an open source project. And you can get started with it today at khlens.dev. I'm going to hand it back over to our host. Nana, thank you so much for participating here with me today, sharing with everybody the challenges and so forth. I do want to stop just a minute before because I'm sure people have some feedback, questions, and so forth. So thank you.
All right, excellent. I'll just echo what Brandon said from the audience, which was great discussion. He said that so far, but so do you guys have a couple of minutes to just go over a little bit with some audience questions?
Absolutely.
Super.
Yeah.
Okay.
Mm-hmm.
So the first question comes from Mikhail, who's asking, if I run my Kubernetes cluster in a Ubuntu headless virtual machine and control remotely from a Windows PC, can I install Lens on the Windows PC and access the Kubernetes cluster of the Ubuntu virtual machine?
Yes, the answer is yes. You absolutely can. Lens also works in air-gapped environments and so forth. So yes, the answer to that is yes.
Okay, super. Next
as
question
long
comes
as you're
from
running a certified Kubernetes distro, it works. Sorry to interrupt.
Okay. No worries. Next question is a self-hosted web version of Lens planned? Subhanan says it could help a lot to manage and facilitate cluster access.
That's an excellent question. Yeah, that's an excellent question. So it is a roadmap item. That being said, we are quite far away from implementing a Lens browser version, specifically because there's so many vulnerabilities that come with having a website browser, specifically because at that point you're kind of connected to the internet, right, at all times, and there's a ton of hoops that we need to jump through from a security vulnerability standpoint. So we absolutely will be releasing a Lens website browser version, but that being said, it's far from being implemented, and I believe we are about a year away.
Okay. All right. Florin is wondering, can Lens validate from a security standpoint the images before they actually get started?
No. Lens cannot, and I mean, maybe we need to elaborate here further. When we say validate, are we being specific to ensuring there's no vulnerabilities for that image? And if that's the case, no. That being said, we do have a new feature set coming to Lens specifically for all security aspects of Kubernetes, whether it's container security vulnerabilities, image security vulnerabilities, and so forth. That's going to be released relatively soon with several features really focused on cluster security, container security, image security, and so forth.
Okay, super. Got time for maybe let's try maybe two more questions. There's one here from David. How does Lens differ from the management tools that come with some Kubernetes cluster managers like Rancher or Anthos?
That's an excellent question. So, for example, Lens is going to work with any certified Kubernetes distro. It's also going to give you a terminal that's going to allow you to interact with that cluster through kubectl, as well as being able to deploy resources through YAML and so forth. From my understanding, Rancher, and I don't have the best take on Rancher, but from my understanding with Rancher is you can only actually not only, but my understanding of Rancher is it's really, Rancher Desktop is what I'm referring to, is it's really more specific towards similar to like Docker Desktop, where you're like building images or containerizing applications and so forth, compared to Lens, where it's really an observability tool or a troubleshooting tool or a debugging tool across any environment. So maybe I need to learn a little bit more specifically about what you're referring to with Rancher, but that is my understanding.
Okay, super. And a nice question to take us out on here is one from Sunny, who's asking, is there any tutorial to learn Lens?
Absolutely. Absolutely. You can Google Lens on YouTube. You can Google just Lens tutorials. There's countless blogs written by our community. Some are written by me. But there's countless Kubernetes influencers, community members that have written blogs, that have posted YouTube videos and so forth, really with a detailed breakdown of how to leverage Lens. That being said, I do want to share with this group that all you need to do is add a kubeconfig cluster to Lens, and Lens's UI is so simple that I think your user experience is going to be fantastic, whether you leverage a tutorial or not.
Okay. All right. Fantastic. Well, Edward and Nana, thank you so much for being on today. Unfortunately, there are way more questions than we could get to today, but we'll get those to you so that you can get in touch with people directly. But great presentation. Appreciate the demo and for all the insights in the Q&A. Thanks a lot.
Thank you.
Thank you. Thanks a lot.
And before we wrap up, we do have one more piece of business. It's the prize drawing for the $300 Amazon gift card. And the winner today is Justin Gunderson from Wisconsin. So congratulations to Justin. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Mirantis for making this event possible. And thanks as always for attending and for all of your great questions. That concludes today's event. Have a great rest of your day.